Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to the audience. Alright, so basically today we continue with the topic fundamental of thermodynamics. Okay, so the topic today is on air standard cycle part 3, which we are focusing on diesel cycle. Okay, so as per introduction to diesel engine, sorry, diesel engine. Okay, so basically known as compression ignition or CI engine is an internal combustion engine in which ignition of the fuel that has been injected into the combustion chamber is caused by the high temperature which a gas achieve, for example the air. So when greatly compressed, so basically we assume this compression is adiabatic compression. Okay, so basically here we know that the diesel oil, okay, so basically can be ignited automatically if the parameter such as the pressure and the temperature, the optimum parameter is achieved. So basically it will automatically ignite. So the original cycle proposed by Rudolf Diesel in 1892, which would require much higher compression than what is needed for compression ignition. So Diesel's idea was to compress the air so tightly that the temperature of the air would exceed that of combustion. The compression ignition engine has the highest thermal efficiency, engine efficiency, of any practical internal or external combustion engine due to its very high expansion ratio and inherent lean burn, which enable heat dissipation by the excess air. So normally the diesel engine is used for heavy duty transportation due to high torque produced by the engine. So basically if you look this figure on the right side, so this is the example of diesel engine. So this is the parts in the diesel engine, which is this is the compressor. Okay, so basically this compressor is used to compress the air to increase the pressure. Alright. Okay, this is the example of diesel engine. Okay, four-stroke compression ignition diesel engine. So basically the basic difference between a diesel engine and a gasoline engine is that in a diesel engine the fuel is sprayed into the combustion chamber through fuel injector nozzle, when the air in each chamber has been placed under such great pressure that it's hot enough to ignite the fuel spontaneously. So if you look into this figure, sorry, you look at air intake and then it's being compressed, the fuel is being injected while the compression takes place. Okay, here you see that we don't have any spark plug. So diesel engine does not require a spark plug because the diesel fuel is automatically ignite based on the pressure and the temperature. Okay, so the uh, the figure is much similar with the petrol engine. Okay, so we have a intake stroke, compression stroke, power stroke, and also exhaust stroke. Okay, it's much similar with petrol engine, just the difference is in the spark plug. Okay, okay, so basically here this is the PV diagram for ideal cycle compression ignition engine diesel cycle. Okay, so the difference between diesel or with petrol is that process 2 and 3. Okay, from petrol engine, the process 2 and 3 is at constant volume, but here process 2 and 3 is at constant pressure. So that is the main difference here. Okay, so as we have a constant pressure process here, we have another compression ratio. We call it as a cutoff ratio. So cutoff ratio shows that the process 2 and 3 is at a constant pressure. Okay, so this is the ideal formula related with the diesel cycle. Okay, so process 1 2 is a isentropic compression, so this is the basic formula. Process 2 3, okay, here is the difference, constant pressure. Okay, so basically from the diesel petrol engine, we have a constant volume. Okay, so here is the constant pressure. So by this constant pressure, we have a CP, specific heat at constant pressure, compared to petrol engine is CV, constant volume. Okay, so process 3 4 remain the same, and process 4 1 also remain the same with petrol engine. Okay, so the thermal efficiency of diesel engine is similar with a petrol engine, where we have a work net divided by Qin. Okay, so from this work net we can more calculate. Okay, we can further details. Okay, we have work net is your at pressure P2, volume 3 minus volume 2, this is your volume. Okay, so here compared to petrol engine, we have only two volume. Okay, so this is a constant volume and another is at constant volume back here. Okay, but for diesel engine we have three volume. So this is one volume, this is another volume V3, and 2 is also another volume. So we have three volume. Compared to petrol, we have only two. Okay, alright, so and then this is the process for goes for 1, and then from this equation we can simplify that the efficiency for the diesel engine is, we have the okay, so this is the efficiency for diesel engine. Okay, here the additional, because of process 2 and 3 is at constant pressure, so we have a cut-off ratio. So cut-off ratio is the ratio between the value of V3 volume 3 per volume 2. Okay, so whereas your normally the ratio, compression ratio, is by maximum per minimum. So the minimum normally is at 2, because for diesel cycle we have 3 volume, so we have another ratio, we call it as a cut-off ratio. So cut-off ratio substitute into your general equation, so you have, this is your efficiency for diesel engine. Okay, so we have a RC is a cut-off ratio, right? Okay, so this is the main difference between the petrol engine and diesel engine. So petrol engine, we have the air fuel mixture compressed to a temperature below auto ignition temperature of the fuel. So normally here we use a petrol engine lah, petrol fuel lah, petrol. Okay, whereas for diesel, the air is automated ignite by temperature, okay, and also the pressure, right? So petrol engine use spark plug, diesel use only doesn't need a spark plug, it's automated. Okay, so petrol engine have a mixture of air and fuel and compressed during a compression stroke. So basically for diesel engine, only air is compressed during compression stroke, and the fuel will be injected during compression stroke. Okay, so petrol engine have a compression ratio 8 to 12. Okay, basically for diesel engine we have a higher compression ratio, either at 14 to 25. So basically petrol engine will produce more high speed but lower torque. For diesel engine, higher torque but lower speed. So which mean here, high speed kereta lebih laju ataupun motor lebih laju. Diesel engine slow but pick up lagi power. Alright. Okay. Sample problem 5.3. Okay. Sample problem 5.3. An air standard diesel cycle has a compression ratio of 18 and cutoff ratio of 2.5. The state at the beginning of the compression is fixed by P 0.9 bar and the temperature is 300 Kelvin. Okay, so that is your P1 and T1. Okay, using constant specific heat values at room temperature, calculate 1. Thermal efficiency, 2. Maximum pressure Pmax, okay, and 3. the mean effective pressure. Okay, 5.3. So we have PV. Okay, so 0.1, right? So is a isentropic compression. So 0.2. Okay, constant pressure, heat addition at constant pressure, and isentropic expansion 2.4, back to initial. Okay, so this is your Q in. Okay, so given at P1 0.9 bar. Okay, so you need to convert into kPa. Okay, and T1 is 300 Kelvin. Okay, so that is in the question. Okay, thermal efficiency of the cycle. Okay, so before we calculate, so we need to determine the pressure and temperature at each point. Okay, so we go one by one. Process 1, 2. Okay, so at 1, 2 is a isentropic compression. Isentropic compression, because we are dealing with air. Okay, so given P1 and also your compression ratio RC 18, cutoff ratio. Cutoff ratio, what is the value of cutoff ratio? Okay, so this is RC cutoff ratio 2.5. Okay, all right. So the isentropic 0.12, the correlation is isentropic. So we got P1 over P2 is equal to V2 over V1. K is equal to T1 over T2. K minus 1. Okay, so K is with refer to the appendix. K is 1.4. K 1.4. Okay, and so the compression ratio is 18. So P1 0.9 bar. P2. Okay, so compression ratio 1 over 18. K 1.4. So P2, if you have convert, this I have not converted yet, so I use a bar. If you have converted, so you can convert into kPa lah. Okay, alright, same goes with temperature. So temperature 1 over 18, 1.4 is equal to T1 over T2, 1.4 1.4 minus 1. Okay, so T1 is 300 Kelvin, so T2 we can calculate unit Kelvin. Okay, so we got 1 and 2. Okay, so 2 3. Okay, so 2 3 is a isobaric. Okay, heat addition. Okay, so basically in this example, how much the heat being added is not mentioned. Okay, so we need to determine by using the PVMRT lah. Okay, so P2 V2, okay, MRT2 is equal to P3 V3 is MRT3. Okay, so MR, okay, because constant pressure. So we got V2 over V3, T2 over T3. Okay, so 2 3 is a cutoff ratio. Okay, so it's a cutoff ratio, V2 over V3, so 1 over 2.5 T2 over T3. So therefore T3 Kelvin. Okay, and P2 is equal to P3. Okay, it's a constant pressure. Okay, what's next is to determine the 3 4. Okay, so 3 4 is a isentropic compression. Okay, we have 0.3 and 0.4. So the correlation between 1 and 3 4, we need to determine the 0.4. So we can use a data from 0.1. So 0.124 or 1.4. 1.4 is a constant volume. Okay, it's a constant volume process. Okay, so by using this constant volume, so we can P4 V4 MRT4 is equal to P1 V1 MRT1. Okay, so M R, okay, volume, okay, so we got P4 over P1 is equals to T4 over T1. Okay, and from process, okay, from process T4, okay, P4 per P3 is equal to V3 over V4. Okay, K. Alright, so V3 over V4, okay, we don't know the value. Okay, so using the ratio, Okay, using the ratio, so V1 over V2, I space. Okay, so I move on into this. Okay, so P4 P1 T4 T1 P4 T4 T1 T4. Okay, and here we have P3 V3. Okay, P4 over P, and P4 over P3 is equal to V3 over V4. Okay, alright, so in this example, okay, we don't know the point at 4, temperature at 4, 4. Okay, so P4 we don't know, T4 we don't know, we have P1, so this is P1. P1 we got the value, T1 also we got the value. Okay, alright, so from this we know that V2 V1 is 18. Okay, and V3 V2 is the cutoff ratio is 2.5. Okay, that is a cutoff ratio. Okay, right, so V3 is equals to, okay, 2.5 V2. Okay, so substitute V and V2 is also V1 18. Okay, substitute, so V3 is 2.5 V1 18. Sorry, this is V1 over V2. Sorry, this V1 over V2 is 18. So we got here, okay, V2 V1 is 18 V2. Okay, similarly, okay, V2 is equal to V1 over 18. Okay, so V2 convert here, so V3 2.5, okay, V1 over 18. Okay, alright, so substitute into this equation, so P4 over P3 is equal to V3 okay, V4 is equal to V1 because constant volume. Okay. Okay, so you can rearrange as we know the value of P3. Rearrange the volume V1. Okay. Rearrange. So, okay, as your PV, P1, V1, okay, MRT1, okay, so this is volume kg, so we got PV1, RT1, this is one, okay, so R, universal gas constant, 0 point something, so 0.28. R is 0.287. Okay, so T1 300 Kelvin, P1 0.9, so V1 specific volume 1, so you can get meter cube per kg. So substitute into this equation, so you got your P4. If you don't convert, if not, it's a bar. Okay, so from this we can determine okay, so therefore, okay, so P4 T4 is equal to P1 T1. Okay, so T4, okay, P4 times T1 over P1. Okay, so you can get your in Kelvin. Okay, alright. Okay, then we need to determine the thermal efficiency of the cycle. So efficiency of diesel. Okay, so we got 1 minus 1 over R compression ratio, K minus 1. Okay, R compression ratio, cutoff ratio, K minus 1 over K R compression ratio minus 1. Okay, so the compression ratio is 18, cutoff ratio is 2.5. So you can get your times 100, you got percentage lah. Okay, alright, so number 2 is maximum pressure. This is 1, 2, max pressure. Okay, so P max is P2 is equal to P3. So we have determined P2 and P3. Okay, bar. If you not change to kPa. Number 3 is mean effective pressure. Okay, so MEP is work net. Okay, work net, V max minus V min. Okay, so V max here, so
sorry, work net out, Q in minus Q out. Okay, Vmax, as we have the max is V1. Okay, the lowest part is V2. Okay, so rearrange. Okay, so rearrange. So we got Q in minus Q out over V1 1 minus 1 over R, compression ratio. Okay, Q in. Okay, so C Q in is a CP constant. Okay, so T3 minus T2 is a constant pressure. Okay, so we have T2 CP. Okay, this unit we don't include mass. Has been put below, so we have a kilojoule per kg. Okay, and Q out CV, because it's at a constant volume 4:1. Okay, so T4 minus T1, so kilojoule per kg. So substitute your Q1, Q2. Okay, so you can get in. Okay, if you use a bar. If you not, you use a kPa. Okay, so if you have converted, kPa lah. Okay, if not, bar lah. Okay, alright, thank you.